We've talked about how computers work individually, with both their hardware and software components performing in conjunction. But what about computers working together? When you open up your laptop to finish an essay and you look up some sources, you're searching online to find information that's not on your own computer, but is somewhere on the internet. When you go on your phone and send text to your friends or scroll through Twitter, you're interacting with other devices using your phone. When you place an order on Amazon, your device is sending an order that will affect Amazon's online database. I think you get the idea. Computers are capable of communicating with one another, and when they do that, you open doors to greater productivity and the sharing of information. Let's start from the basics. A network refers to two or more computers that are connected together so that they can share information and interact with one another. We call a computer connected to a network a host. Let's take a look at a very simple computer network. This is something that you might see in a very small office. It's basically just four computers hooked up to a printer and a file server. Since these computers are connected in a network with the printer, they can all send files to be printed by this same printer. This file server over here is basically just a computer that has a large amount of secondary storage to store programs and data needed by all the other computers. So maybe all the important files that everyone in the office needs to access, or maybe a program that everyone uses, it's being stored in this file server. The nice thing about the file server is that since it's also connected to the network, each individual computer doesn't need to have its own individual copy of all the programs and files stored on here. Okay, but how exactly are we connecting the computers? Let's put this office aside just for a second and think even more simply. How do we connect just two computers? Well, your first instinct might be just to directly connect two computers with a wire. We can sort of picture that as plugging your phone into your laptop with a USB cable. At that point, the two computers communicate just like the bus wires communicate inside of a single computer. This is called a point-to-point connection, and it works for two computers that are physically close to one another, but what if we have a lot of computers that aren't in the same place? If we try using point-to-point connections, we need to connect each computer to every other computer in the network directly by wire. So if we had 5 computers, each computer would have to be directly connected to every other computer, like this. So if we had 1, 2, 3, 4, 5 computers, the first guy would be connected to the other 4, like this, directly by wire. The next one, same idea. The third computer, same process, and the last one connects right here. This isn't really a practical solution since every time we add a new computer to the network, we need new communication lines for every computer that's already in the network. So point-to-point connections aren't really useful for large groups of computers, but what about the connection we have going on in our office over here? In this picture, all the computers are sharing this single communication line. This shared communication line is a lot cheaper than having to install individual wires to every single computer every time you want to add another component to your network. In this sort of system, each computer has its own network address, which is basically its unique identifier. This is analogous to memory addresses, except it's the address of a computer in a network of multiple computers rather than the address of a memory location in main memory of a single computer. But it's the same idea. If the guy at this computer wants to send a message to his coworker, maybe has an email typed up or something, well, he can just specify the network address of the other guy's computer, and then the message can be sent. It'll follow the network address and know where to go. There is a problem, however, with shared lines: delays. The computers on the network can't use the communication line at the same time. They have to take turns, so if everyone's trying to send something at the same time, it'll take a while. Well, what if we had a situation where someone's sending a really large file? Let's go ahead and try to visualize this. Let's say we have 4 workers in this office. Let's say this one's Jim, maybe this can be Dwight, maybe this is Angela, and maybe this guy could be Michael. Let's say Michael here downloaded all 14 seasons of Grey's Anatomy, and he wants to send it to Jim. Well, with 45 minutes per episode and 22 episodes per season, that's a lot of data to be transmitted. At the same time, Angela has to send over some important accounting documents to Dwight so he can finalize it for their headquarters to see. Is Dwight going to be waiting forever while Michael's 14 seasons of Grey's Anatomy are sent over? Well, luckily, no. In order to prevent huge network delays like the one we have going on here, large messages are divided into smaller segments called packets, and then the packets are sent through the network with other messages mixed in. So maybe 2 packets of Michael's files go through, and then Angela's files, and then a couple more packets of Michael's, and then maybe some other files from Jim, and then some more of Michael's, and so on. The individual packets are collected at the destination, and then they get reassembled into the original message. That way Jim doesn't end up with a bunch of fragments of Grey's Anatomy. He gets the original files, but Angela gets to send her files on time too. Okay, so that's the basics of how networks work in general, but let's get into some different types of networks. A local area network, or a LAN, is a type of network that spans short distances and connects a relatively small number of computers. So if we had just one office building, or even one floor of an office building, those computers might be connected in a LAN. LANs are useful since they're easy to install, easy to manage, and are reliable overall. However, more often than not, we need to send information across much longer distances than just one building. A wide area network, or a WAN, connects two or more LANs over long distances. So maybe we'd have something like this, so where we have 3 LANs connected to make one WAN. So we have our first LAN over here, our second LAN over here, and our third LAN over here, and they're all connected. And we can see that at these connection points, the LANs each have a specialized computer that's dedicated to just handling the long distance communication. That way the other computers don't have to worry about it, and you don't need every single computer to be able to do long distance communication. They can sort of piggyback off of this specialized one. And well, what's the greatest distance a wide area network can cover? Well, that depends, but it's pretty far. These different LANs might be in different buildings, different cities, different states, or even different countries. You might be able to see where we're going with this. We connect individual computers together to create a local area network, and then zoom out a little, we connect local area networks together to create wide area networks. What if we kept connecting these networks? Well, that's how we'll develop the internet.